Okay, before I pergi kepada example E, 10.3, just want to touch a little bit on azeotrope lah, just in case you have forgotten or you have not learned. I'm not sure whether you have learned it or not. So dia adalah deviation from Raoult's law in terms of, macam kita cakap tadi, Raoult's law dia kata an ideal gas. So dia kata if Raoult's law, the activity coefficient is equal to 1, okay? So this is deviation from that, right? Azeotrope dia pada ketika itu at this condition, it is said that this liquid and vapor composition are the same. Okay, then they have like a constant boiling point, either maximum or minimum boiling point, because after that that's the constant of it, and the composition are also the same. Okay, so we have x1 is equal to y1 for example. Okay, then at azeotrope K is equal to 1, the flash. Okay, flash distillation is equal to 1 and no separation of species can take place. So just an example, you have two things, two composition A and B. Okay, so bila among A interactions are stronger, okay, the activity coefficient will be greater than 1. So this is what we call a positive deviation. Positive deviation, and we can see they have the minimum boiling point. Itu adalah the minimum. Yeah? And at that point, the liquid and vapor composition is the same. Right? So positive deviation here does not mean that it's positive as in it's good. Okay? Tetapi dia nak berkatakan dia is lebih besar daripada 1. So dia positif ke arah besar, bukannya kata baik ataupun tidak. So kalau kita ingat dari equation tadi, 10.5 tadi, modified one. So at azeotrope where this is equal to 1, this is equal to 1, kita kata P is equal to gamma I Pi set. Okay, so if interactions are weaker, kita gunakan, if the interactions are weaker, or the activity coefficient is less than 1, we call it negative deviation, where we will find maximum boiling point. Okay. So kadang tablet ni tak sama dengan screen. So again, this is the condition at azeotrope from the Raoult's law equation. So now we look at example 10.3e tadi. So dia kata calculate the azeotropic pressure and azeotropic composition for temperature adalah 45 degree Celsius. So at 45 degree Celsius ni, berapakah pressure di mana both liquid and vapor composition will be the same, and they will have a constant boiling point, right? Either maximum boiling point or minimum boiling point, doesn't matter. And what is the composition? Okay, so the azeotropic condition ni berubah-ubah. Kalau I kata, okay, for temperature 100 degrees Celsius, the azeotropic pressure will be the same. Different. Okay, so you can recalculate and sebagainya. So first of all, we check whether or not there is a condition where azeotropic exists at the given temperature. Boleh ke tidak jadi? Kita tak tahu. Okay, so we know that at azeotropic, yang ini tadi syarat dia, okay, right, alpha 1 2 is equal to 1 lah, sebab berdasarkan yang ini tadi kan. Dan from the equation, this one is from 10.8, okay, yang ini tadi 10.8, 10.8, yang ini tadi yang biasa lah 10.5. Okay, so kita akan dapati y1 over x1 is equal to this one. Okay, sebab x1 is equal to y1. Okay, dan kita tahu, kita tahu that y1 over x1 is equal to gamma 1, tak nampak, equal to gamma 1 P1 set over P lah. Kita modify balik. So then Y1 bagi dengan X1, Y2 bagi X2. Kita bagikan ini, masukkan balik ke dalam equation ini. So, kita akan dapat equation ini. Derivation dia adalah pada 10.9. Okay. Very simple calculation lah. Okay. So, kita tengok when X is equal to 0, okay, gamma is equal to this value. Okay, when x1 is equal to 1, gamma 1 is equal to 1, gamma 2 is equal to this value. So, kita cari the value lah. Okay, so these are the limit. Okay, so right, ni tadi saja nak cerita je lah. Okay, ni tadi question tadi lah. So, bila kita check the limit, if the limit adalah greater than 1 and the other limit is negative 1, bermaksud dia ada satu deviation lah. Yeah? Bermaksud azeotrope exists. Sebab dia mesti duduk between 1 dan lebih dari 1 lah. Okay? Janji, maksudnya macam ni. Katalah you dapat satu nilai you dapat 10, satu nilai you dapat 3. Okay. Maksudnya azeotrope tak exist sebab dia tidak menepati syarat ini. Syarat dia adalah satu mesti lebih daripada satu mesti kurang daripada 1. There are the limit. Okay. Maksudnya macam ni. At x1 is equal to 0, maksudnya tak ada liquid kan? Sorry, tak ada liquid. At x1 is equal to 1, bermaksud tidak ada vapor. So, kita calculate for these both cases and we find the limit. Right? So, for example, yang tadi kita dapat adalah alpha, sorry. Okay. Yang tadi kita dapat alpha 1, 2 pada X sama dengan 0 kita dapat tadi. Sorry. Okay. So, kita dapat tadi yang ini tadi kita dapat 2.052. Yang ini kita dapat 0.224. So, what happened is that this limit bermaksud 1 is in the middle. Correct? It's between less than 1 to more than 1. So, 1 is in the middle. Okay, kalau you tengok kat sini. So, you akan dapat 0.224. Okay, 1, 2.052. So, if 1 is in the middle means that the azeotropic condition exists or can exist at the temperature given. Okay, sebab tak semestinya keadaan azeotropik ni boleh berlaku pada any temperature ataupun any pressure. So, kita check dulu. So, when you have the value of the limit of alpha 1, 2 is actually between 1, that means it exists. Macam saya cakap tadi, kalau you dapat 1, you dapat 10, satu lagi dapat 3, tak boleh. Maknanya azeotropic does not exist for that temperature. So, tak perlu kira berapa pressure dia atau berapa composition because it doesn't exist. Okay. So, sambung tadi. Mak tak ada lah pula. So, you boleh check dekat textbook lah. Untuk sambung, untuk kira. Okay. Okay. So, this is the sort of like a summary. So, kadang-kadang kita ada given mixture. Okay, kita given temperature, kita given pressure, kita kena cari sama ada bubble point temperature ataupun bubble point pressure ataupun dew point temperature, dew point pressure. Macam saya cakap tadi, pusing-pusing balik, those are the things that you have to do, balik-balik benda tu. Okay, I can put any temperature, I can put any pressure, I can put any composition. Boleh? But the step will be the same. So, you have to understand, kalau saya bagi soalan, because everything will be online, so mungkin soalan anda tidak akan sama dengan your friends. Okay. So, that's why I said, walaupun mungkin kawan you dapat soalan lain, temperature berbeza, composition berbeza, but the step, anything adalah sama. Okay. Right. So, kalau bubble point, kita kata liquid tu tidak significant. Yang biasanya kita beri fraction dalam bentuk gas. Okay. So, kita perlu satisfy equation 10.14. Kalau dew point, system is almost condensed. Yang given, mole fraction, need to satisfy equation 10.13. Okay. Right. So, itu saja dulu.